This is ISACA's Page 2 podcast.
Hello, I'm Kevin Key, ISACA's IT Professional Practices Lead. Oh, thank you so much for joining me today. How are you?
Great. And I live in sunny Connecticut today. Sun is coming out and it's pretty warm. Nice here.
Yeah, I'm in Maryland and it's about 60s, low 60s right now, so not too bad. But let's get right into it. What are the main competitive advantages to be gained through secure machine learning?
For many companies, they want to know their customers. So they want to use machine learning to validate who they are doing business with. And they want to use machine learning to find new opportunities. I think those are kind of where most companies start. And for example, it can be in pharmaceutical. They use machine learning to quicker find new drugs and validate new drugs. In the financial industry, in many cases, it's about KYC, know your customer, anti-fraud analysis, and it's becoming more and more an integrated part with applications. So part of the business logic is done in traditional applications, and more is done in machine learning, without the programming. So machine learning is looking at your data and basically trying to find patterns and learn from historical data or historical analytics.
Awesome. So tell us a bit about why new techniques such as TEE and tokenization fabrics should be on practitioners' radar.
When we talk about TEE, it brings more security to cloud. So cloud is distributed software that you share with a lot of other players. So you don't know who is running next to you in the cloud. It could be a bad guy. For example, TEE, Trusted Execution Environment, is a piece of hardware where you can protect data and code. So you can run your most sensitive machine learning algorithms in that trusted execution environment. So it's kind of a middle ground. You still run it in cloud, but you are not running it in a shared environment with everyone else in the public cloud. And the second part here is tokenization, protecting your data. If you don't trust your infrastructure, if you don't trust the cloud, the administrators, attacks can go on. You don't know what administrators are looking at. Tokenization can provide security for your most sensitive data. So instead of exposing your sensitive data in cloud, instead of exposing encryption key that is encrypting your sensitive data in cloud, tokenization takes another approach. Tokenization is replacing your most sensitive data with a pointer. So that token has no value to an attacker because they cannot revert the token back to clear text. And there's no encryption key hanging around in the environment. And tokenization became the standard for protecting cardholder data, protecting payment information. So Visa, MasterCard, and other card brands and payment systems, they started to use tokenization as a better way to protect sensitive data. So that was a long answer.
No, so we're talking about tokenization, protecting sensitive data, but what are the challenges that come into play with synthetic data?
Yeah, synthetic data is a replacement for your sensitive, maybe regulated data. So there are two types of synthetic data. The most simple type is just artificial. It's generated data. There's no link to your sensitive data or your regulated data. So from a compliance point of view, there is no concern. And still synthetic data can mimic the results that you get from clear text data. So analytics, statistics can be highly accurate. The other type of synthetic data is actually when you take business data and generate some of the synthetic data based on your real business data. And in that case, you need to go in and measure how much privacy risk am I taking since it's generated from our business data. So in that case, you go in and balance the high quality in that generated data versus your privacy risk. It's a very interesting way of replacing sensitive data with alternatives that you can use for many business cases, particularly in test environments and in analytics for machine learning. Unfortunately, you cannot get the data back. So synthetic data is not reversible. So for use cases where you absolutely need to get your data back, you need to use encryption or tokenization instead. And it could be in a clinical test where you need to go back and find who was this patient with this bad outcome. But for simple test environments and analytics where you only look at statistics, you can go with synthetic data. And it's emerging. It's emerging and becoming more frequent.
So it's funny you bring up emerging technology. You mentioned machine learning. So to go even more into emerging technology, what do you consider to be the main pros and cons with quantum computing?
Quantum computing is great because it's a faster computer. It's something that also can be a threat because it can break certain type of encryption algorithms much faster than current processors. For example, asymmetric encryption, public key encryption, algorithms like the RSA algorithm, ECC algorithm, elliptic curve, those are in danger. So a quantum computer can attack all the data that you are using for the internet. For example, TLS, SSL TLS, encryption, and also historical data that is around. And when the quantum computers are becoming more practical, they can start to be used to expose and decrypt all your historical data where you used asymmetric encryption. If you are using AES or other symmetric encryption, block ciphers, that you are more secure. You just need to bump up the encryption key. So maybe move to AES 256-bit key, and you will be safe for a pretty long time.
So with quantum computing, I know it's in the early stages. A lot of the big players in the game are starting to develop their own quantum computing technology. But how do you envision the quantum environment changing over the next 5 to 10 years?
We are starting to see the major cloud providers like Microsoft providing environments where you can use quantum computing as a service. It's an easy way to dip your toe and test out quantum capabilities. And I think in that time frame, you mentioned 5 years, there will definitely be real commercial offerings in the cloud and practical use cases. It's you mentioned 10 years. In 10 years, you may see that the RSA algorithms are cracked and exposed. And in that time frame, you probably will see a lot of business benefits, in particularly in financial services industry. And we talked about machine learning initially. There are certain machine learning algorithms that are very suited to run on a quantum computer. So the nature of the machine learning algorithm is highly suited for that parallel processing. So that's another benefit. It's not just the speed.
Well, in your view, is the security community paying enough attention to the implications of quantum computing?
Uh, Many people are saying, well, that is down the road. It will not be here soon. And yeah, it will not really be practical anytime really soon, but it will starting to impact us in a couple of years. And if you want to replace vulnerable algorithms like RSA in algorithm in TLS encryption, then you need to start planning now, because it will take years to replace that infrastructure. For example, if you want to replace RSA encryption with one of the top candidates, lattice-based encryption, then you need new certificates. So new certificates for TLS. And you need to replace all that infrastructure, and it will take time. So I would say you should start planning right now.
Great. And what interests you the most about some of the research being done on post quantum cryptography?
We are having a lot of great research by NIST, National Institute for Standards and Technology in US, which is guiding not just US, but the whole world regarding quantum computing and post-quantum algorithms, post-quantum cryptography. So they have been evaluating and studying new algorithms that can replace, for example, better hashing algorithms instead of the SHA-1 and longer SHA hashing algorithms. And of course, the asymmetric algorithms that we talked about before, like the RSA. And some of those are based on what I mentioned before, lattice-based encryption. And lattice-based encryption is basically a large lattice where you are solving vector problems in those lattices. So that is how you can a little bit compare it to elliptic curve equations. And these lattice-based algorithms, some of them are used in quantum and homomorphic encryption, where you can do operations on encrypted data. So several of those new algorithms are useful for a number of emerging areas.
To move the conversation along with emerging technology, blockchain is also in that conversation. So, what are your thoughts on blockchain security considerations that enterprises should be mindful of if they have implementations on their radar?
Yeah, blockchain is, according to Gartner and other analyst firms, taking off. We've been waiting for many years for real business impact, and in the next few years, it will take off. So it will dramatically impact businesses like financial services and other businesses. For example, in areas like smart contracts, where you establish a peer-to-peer contract between two parties without any central authority. And of course, we will see more and more payments systems utilizing the fast payment capabilities of blockchains. We have seen Bitcoin and other examples for payments, and Ethereum is now increasing capabilities and popularity for smart contracts and utilizing the new peer-to-peer operations and highly mobile peer-to-peer that is basically a very interesting use of the internet without, or let me put it like this, we have been living through Web 1 and Web 2, and now this new Web 3 that is emerging is very interesting from the blockchain perspective and other perspectives. So we started with Web 1, that was simple web-based interactions, and then Web 2 was exploited by Facebook and other organizations that made use of the Web 2 technology. And now we are seeing Web 3 coming in with this more mobile to mobile communication capabilities. It's very application centric, using internet service providers as the network for communicating. And when you are saying that blockchain, it started with payments, but there are more and more industries that are finding use cases for blockchain. We had initially some performance problems and scalability problems with Bitcoin, for example, where they had a very heavy confirmation of transactions based on amount of work, proof of work. And now we are seeing new technologies that are have lighter confirmations, lighter, quicker confirmation protocols. Some are based on proof of stake instead of proof of work. And I'm very excited about areas like smart contracts, and we're seeing across different industries that they are starting to benefit greatly from this general ledger approach. So in general, it can be applicable in many areas where you need to have data lineage, where you need to prove a certain transaction history. So not just financial ledger systems, but owning assets, where you need to prove what happened to those assets over time.
It's great. You've actually provided great information. Is there anything else that you would like to add?
I think that these technologies that we are talking about is sometimes misunderstood. There's a lot of confusion because some of these technologies they look the same, but they are very different regarding what use cases they solve and level of privacy and security that they provide. So I think that it's a good investment to get educated and learn a little bit about these different technologies and techniques, because they are definitely starting to change the landscape, and there can be a lot of use cases that will be enabled by these technologies.
That's all the time we have. Ulf, thank you so much for taking the time to chat with me today. I am Kevin Key, and thank you for tuning in.
Thank you. And I like your guitar. I used to have a Fender myself.
That's awesome. That's awesome. Thank you.
Take care.
Thank you for joining us today for this episode of Page to Podcast. We hope you enjoyed this episode.